Chapter 3: Ethereum Clients. An Ethereum client is a software application that implements the Ethereum specification and communicates over the peer-to-peer network with other Ethereum clients. Different Ethereum clients interoperate if they comply with the reference specification and the standardized communication protocols. While these different clients are implemented by different teams and in different programming languages, they all speak the same protocol and follow the same rules. As such, they can all be used to operate and interact with the same Ethereum network. Ethereum is an open source project, and the source code for all the major clients is available under open source licenses, free to download and use for any purpose. Open source means more than simply free to use though. It also means that Ethereum is developed by an open community of volunteers and can be modified by anyone. More eyes means more trustworthy code. Ethereum is defined by a formal specification called the yellow paper. This is in contrast to, for example, Bitcoin, which is not defined in any formal way. Where Bitcoin's specification is the reference implementation Bitcoin Core, Ethereum's specification is documented in a paper that combines an English and a mathematical specification. This formal specification, in addition to various Ethereum improvement proposals, defines the standard behavior of an Ethereum client. The yellow paper is periodically updated as major changes are made to Ethereum. As a result of Ethereum's clear formal specification, there are a number of independently developed yet interoperable software implementations of an Ethereum client. Ethereum has a greater diversity of implementations running on the network than any other blockchain, which is generally regarded as a good thing. Indeed, it has, for example, proven itself to be an excellent way of defending against attacks on the network, because exploitation of a particular client's implementation strategy simply hassles the developers while they patch the exploits, while other clients keep the network running almost unaffected. Ethereum networks. There exists a variety of Ethereum-based networks that largely conform to the formal specification defined in the Ethereum yellow paper, but which may or may not interoperate with each other. Among these Ethereum-based networks are Ethereum, Ethereum Classic, Ella, Expanse, Ubiq, Musiccoin, and many others. While mostly compatible at the protocol level, these networks often have features or attributes that require maintainers of Ethereum client software to make small changes in order to support each network. Because of this, not every version of Ethereum client software runs every Ethereum-based blockchain. Currently, there are 6 main implementations of the Ethereum protocol, written in 6 different languages. 1. Parity, written in Rust. 2. Geth, written in Go. 3. CPP Ethereum, written in C++. 4. Pi Ethereum, written in Python. 5. Mantis, written in Scala. 6. Harmony, written in Java. In this section, we will look at the 2 most common clients, Parity and Geth. We will show how to set up a node using each client and explore some of their command line options and application programming interfaces, APIs. Should I run a full node? The health, resilience, and censorship resistance of blockchains depend on them having many independently operated and geographically dispersed full nodes. Each full node can help other new nodes obtain the block data to bootstrap their operation, as well as offering the operator an authoritative and independent verification of all transactions and contracts. However, running a full node will incur a cost in hardware resources and bandwidth. A full node must download 80 to 300 gigabytes of data and store it on a local hard drive. This data burden increases quite rapidly every day as new transactions and blocks are added. We discuss this topic in greater detail in a future section. A full node running on a live mainnet network is not necessary for Ethereum development. You can do almost everything you need to do with a testnet node. With a local private blockchain like Ganache, or with a cloud-based Ethereum client offered by a service provider like Infura. You also have the option of running a remote client, which does not store a local copy of the blockchain or validate blocks and transactions. These clients offer the functionality of a wallet and can create and broadcast transactions. Remote clients can be used to connect to existing networks, such as your own full node, a public blockchain, a public or permissioned testnet, or a private local blockchain. In practice, you will likely use a remote client, such as MetaMask, Emerald Wallet, MyEther Wallet, or MyCrypto as a convenient way to switch between all of the different node options. The terms remote client and wallet are used interchangeably, though there are some differences. Usually, a remote client offers an API such as the Web3.js API in addition to the transaction functionality of a wallet. Do not confuse the concept of a remote wallet in Ethereum with that of a light client, which is analogous to a simplified payment verification client in Bitcoin. Light clients validate block headers and use Merkle proofs to validate the inclusion of transactions in the blockchain and determine their effects, giving them a similar level of security to a full node. Conversely, Ethereum remote clients do not validate block headers or transactions. They entirely trust a full client to give them access to the blockchain, and hence lose significant security and anonymity guarantees. You can mitigate these problems by using a full client you run yourself. Full node advantages and disadvantages. Choosing to run a full node helps with the operation of the networks you connect it to, but also incurs some mild to moderate costs for you. Let's look at some of the advantages and disadvantages. Advantages. 1. Supports the resilience and censorship resistance of Ethereum-based networks. 2. Authoritatively validates all transactions. 3. Can interact with any contract on the public blockchain without an intermediary. 4. Can directly deploy contracts into the public blockchain without an intermediary. 5. Can query the blockchain status offline. 6. Can query the blockchain without letting a third party know the information you're reading. Disadvantages. 1. Requires significant and growing hardware and bandwidth resources. 2. May require several days to fully sync when first started. 3. Must be maintained, upgraded, and kept online to remain synced. Public testnet advantages and disadvantages. Whether or not you choose to run a full node, you will probably want to run a public testnet node. Let's look at some of the advantages and disadvantages of using a public testnet. Advantages. A testnet node needs to sync and store much less data, about 45 gigabytes depending on the network. A testnet node can sync fully in a few hours. 3. Deploying contracts or making transactions requires Testether, which has no value and can be acquired for free from several faucets. 4. Testnets are public blockchains with many other users and contracts running live. Disadvantages. 1. You can't use real money on a testnet. It runs on Testether. Consequently, you can't test security against real adversaries, as there is nothing at stake. 2. There are some aspects of a public blockchain that you cannot test realistically on a testnet. For example, transaction fees, although necessary to send transactions, are not a consideration on a testnet, since gas is free. Further, the testnets do not experience network congestion like the public mainnet sometimes does. Local blockchain simulation advantages and disadvantages. For many testing purposes, the best option is to launch a single instance private blockchain. Ganache, formerly named TestRPC, is one of the most popular local blockchain simulations that you can interact with, without any other participants, It shares many of the advantages and disadvantages of the public testnet, but also has some differences. Advantages: 1. No syncing and almost no data on disk. You mine the first block yourself. No need to obtain test ether. Ganache is initialized with accounts that already hold ether for testing. 3. No other users, just you. 4. No other contracts, just the ones you deploy after you launch it, unless you use the option of forking off an existing Ethereum node. Disadvantages: 1. Having no other users means that it doesn't behave the same as a public blockchain. There is no competition for transaction space or sequencing of transactions. 2. No miners other than you means that mining is more predictable. Therefore, you can't test some scenarios that occur on a public blockchain. 3. If you're forking off an existing Ethereum node, it will need to be an archival node for you to interact with state from blocks that may have been pruned otherwise. Running an Ethereum client. If you have the time and resources, you should attempt to run a full node, even if only to learn more about the process. In this section, we cover how to download, compile, and run the Ethereum clients, Parity, and Geth. This requires some familiarity with using the command line interface on your operating system. It's worth installing these clients, whether you choose to run them as full nodes or testnet nodes, or as clients to a local private blockchain. Hardware requirements for a full node. Before we get started, you should ensure you have a computer with sufficient resources to run an Ethereum full node. You will need at least 300 gigabytes of disk space to store a full copy of the Ethereum blockchain. If you also want to run a full node on the Ethereum testnet, you will need at least an additional 45 gigabytes. Downloading 345 gigabytes of blockchain data can take a long time, so it's recommended that you work on a fast internet connection. Syncing the Ethereum blockchain is very input-output intensive. It is best to have a solid-state drive. If you have a mechanical hard disk drive, you will need at least 8 GB of RAM to use as cache. Otherwise, you may discover that your system is too slow to keep up and sync fully. Minimum requirements. 1. CPU with 2+ cores. 2. At least 300 GB free storage space. 3. 4 GB RAM minimum with an SSD. 8 GB plus if you have an HDD. 4. 8 megabits per second download internet service. These are the minimum requirements to sync a full bit pruned copy of an Ethereum-based blockchain. At the time of writing, the Parity code base is lighter on resources. So if you're running with limited hardware, you will likely see better results using Parity. If you want to sync in a reasonable amount of time and store all the development tools, libraries, clients, and blockchains we discuss in this book, you will want a more capable computer. Recommended specification: 1. Fast CPU with 4+ cores. 2. 16 GB plus RAM. 3. Fast SSD with at least 500 GB free space. 4. 25+ megabit per second download internet service. It's difficult to predict how fast a blockchain size will increase and when more disk space will be required. So it is recommended to check the blockchain's latest size before you start syncing. Note: the disk size requirements listed here assume you will be running a node with default settings, where the blockchain is pruned of old state data. If you instead run a full archival node, where all state is kept on disk, it will likely require more than 1 terabyte of disk space.